Okay.
Wake up, this little thing. There you go. Okay. So if there's anybody that just came in and didn't get your stuff back yesterday, just see me after class or in lab if you're in lab after this. Yesterday we did all that stuff here. So if you weren't here yesterday, you should probably watch that video. Kind of see where all this stuff came from. Oh shit. This symbol right here, what does this symbol represent? And kind of like the way I remember it is, it looks like an A missing the little bar in the middle for and. It's amazing. Or it looks like an N for A and B. Or you just kind of remember it. Right. So not surprisingly, well, let's do one example of this before we go on. I don't think we did this one. You guys try this one. You weren't here yesterday. Just try something. See what happens. This is on page. It's on page number. Sorry. So it's 2 pages in. At least makes the room a little quiet. I like that. You guys get that? Yes, okay. One of the easiest ways to do an and is to rewrite it to have n in the middle, or x, or whatever the variable. Here we got n. Can I rewrite that so that n is in the middle of something? Yes. Yes. N is bigger than what? Bigger or equal to -5, while also at the same time, it's got to, and it's got to be less or equal to -1. Now, what I just wrote, does it make sense? And what do I mean by that? Well, if I had a problem, real quick before you finish this out, if I had a problem that said x greater than 1 and x less than -4, that would be a problem. Do you guys see why? What number is bigger than 1 and less than -4? Which number does that? Tell me a number that does that. There's no freaking numbers that do that, right? If you try, you say, okay, well, so, 1 is less than x is less than -4. I don't see the problem, Jeff. And then I get people that give me the graph, and sometimes they did a beautiful thing like this, which doesn't make any sense. Are you guys with me? I'm doing everything I'm doing right now is a mistake. You guys, please, your God, don't circle and say, this is how I do it. No, bad. Makes no sense. Bad. So what the hell is the answer to this then? What would the answer to this problem be? Even better. Even better than no solution, especially when the answer is supposed to be a set of numbers. If my answer is always like a set of numbers, what numbers will be in this set for this? The set will be empty. So there's a symbol we have that's called the empty set. And this is why I think on a few people's papers I said stop writing 0 like this, because that means empty set. It's another way of saying no solution. So when you solve an equation and it's got no solution, you can actually officially put this down. And that means the same thing. The set of all numbers that make this thing work is empty. Well, that's a long-ass way of saying ain't no solution to that thing. You guys, does it make sense? You guys with me? That's why you don't write 0. 0 is an answer. 0 is a number. 0 is something, believe it or not. This is nothing. This is not even 0. Okay. All right. So how do I finish this guy out here? Write your Fibonacci interval notation and graph the bad boy. So sometimes it's easier to graph first. How do I graph this thing? And in this case, on both of those, I'm going to put a bracket because I'm allowed to equal, right? And then fill in the middle with your favorite thing to put in the middle of right, whatever you like. And then now the interval notation comes right off of what I just did. What would it look like, interval notation? Bracket -5 up to -1 bracket. Look at that, isn't that crazy? So the interval notation is just a quicker way to write the same thing that a graph tells you. Just a more compact, quicker way to do it without making a number line thing. Okay.
What if I wrote bracket -5, comma infinity, and comma negative infinity, -1?
That is not an answer, that's actually a problem. Now I can work it out, but I don't work out problems when it's supposed to be the answer. You're supposed to work it all the way out. But do you understand what I'm saying, Martin? I'm sorry.
Yeah.
It's a problem, not an answer. Yeah. I like it. Okay. Moving on. So remember, if you were here yesterday, how do I look at and? And is, how do I look at it like a physical analogy of and? Evil bouncer. Right? Or, you know, a regular bouncer. You got to be this and this and this and this to get in the club. Right? You got to be rich. I'm rich. You got to dress good. Look at me. I dress awesome. You got to have a great car. Look at that beautiful car I got. And you got to be on the list. Oh, shit. Right? So you can do everything except one thing, and you can't get into the set of answers. You can't get into the, yeah, that's the name of the bar. I like that. The name of the bar is set of answers. I like it. Okay. Or, officially it's called a union, or even more officially it's called a disjunction. Right? And is a conjunction. Conjunction, junction. Nobody gets that Schoolhouse Rock? Shit. Alright, guys. So a union, unfortunately in English assigns many different meanings to the word and. Very often when we think of and as you and you, put you together. Math says no, the official meaning of and is you have to be both. If I said you and you, well, nobody is both of you. Nobody's going to come with me. If I said you or you, okay, you could both come. Right? So or is the one that says everybody come on in. You're here, you're there, you're rich, you know Joe the bartender, you're on the list, any of that gets you in. You don't have to do all of it, you can do any of it. The only way you don't get in is if you do none of it, right? So or, and is always going to make the answer smaller, smaller, smaller. It's more and more restrictive. Or is always going to make the answer bigger, bigger, bigger. Keeps on taking everybody. So what would the answer to this be? Oh, why do they put and? I love it. I love typos. Find the union between A or B. Just write all the numbers, yeah. -4, -1, 0. Don't put 1, 1, 2, 2, 3, 3, 1, 2, 3, 4, 5, 6. So or means who gets into the answer? Whoever's in either one, this or this one. And the symbol makes beautiful sense. If I'm like a parent and I'm like, God, this room is so messy. You or you, somebody freaking clean this room. Hey, look, you. Right? That's the way I remember. You or you, I don't care. Somebody do it. So the symbol for union is, thank God, makes sense. A U. That's awesome. So that's you or you. So I can use this symbol right there. That U symbol. Upside down intersection. Okay. So similar thing's going to happen now. A little bit later, in the last section that we look at in chapter 8, the one about absolute value, equations, inequalities. Oh shit. Somehow I relate it to a haunted house and a restraining order, right? This is kind of like a first look at a restraining order. Well, what's a restraining order? It says, I'm here, and you can't be any closer to me than some set distance away, right? So you got to go, that side or that side. Get away from me, right? You see how I said or, naturally. So how would I do x less than -2 or x greater than 4? Well, what's going to be a part of the answer? It's going to be all this stuff. How do I graph this stuff? Yeah, so it's going to be all this stuff or this stuff. So not always, but an or answer is almost always going to look like this. Get away from me. An and answer is always going to be stay close to me. That's why it's a haunted house. Right? I freaking go in a haunted house. I'm like, we might be in a movie. Let's not split the hell up. Let's stay together. Stay close to me. Shit. Or a sandwich. Right? Either way you want to look at it. Now, how do I write the interval notation for this? Oh, shit. What's the interval notation look like for this?
Infinity.
Careful, what kind of infinity? Negative infinity up to? -2. Or 4 up to infinity. So I always look at this little middle section, I always look at that as skip. It's negative infinity to infinity, but skip everything between those. It's kind of like the way I look at it. You don't have to look at it that way. It kind of makes it makes sense that the answer is disjointed. Oh, disjunction. Disjointed just like the image is. 2 sets up here, 2 sets in here. Makes sense. So you guys do number 1. Aha. You number 1. You guys get that there so far? Alright. And this is kind of, it's almost too nice to believe. There's only a few situations that are a little weird with or. But I mean, it's just like we just did. There's -8. What am I going to put on -8? Parentheses. in that way. Help me. And then 5. What am I going to know? 5? Bracket. Good, because there's a lot of equal. What is happening outside? Okay, let's see now. Here, do number do number 3 and 4. It sounds like whatever's happening outside has moved on. This is somebody very expressive over there, I think. Oh yeah, forgot the rules. I like it. Just so you know that both 3 and 4 have strange answers. What? Maybe. Well, let's see. All right, let me see. Are you guys getting those answers for those? All right, now how do I... These aren't really answers yet. You see, there are things to work out still, but this is like so far. So how do I represent this? It's really easy to get this confused. This would have a nice answer if it was and. But what's weird about this is, what number is not greater than -1 or less than 4? Or equal to 4, I mean. There's no number that isn't one of those things, right? Every number that's greater than -1, that's all those. And then all the ones that are less than -1 gets picked up by the other dude. So it's an or, right? Or takes everybody from both sets. Well, together, both sets covers everything. It's like me saying, well, to be in the room over there, you got to be, younger than 6, or you could be older than 4. That's every freaking person. What are you talking about? So everybody can go there. Oh yeah. So here's A greater than -1, bam, greater than -1, and then A less than or equal to 4. Here's 4. So I mean, together, do they leave anybody out? No. It's an or. An and would say the answer is between those two things, right? That's and. Or says I take everybody as long as you're in one of those two sets. And what number is not in one of those two things? No number. So what's the answer? A completely shaded in. Rah.
So it would be or.
The difference.
So,
Seems like it's the difference, a U.
yeah, so if this was an and, the answer would be between -1 and 4. Because and says you have to be in both sets. Since it's an or, it says you just have to be in at least one of the sets. That means it covers everybody. Nobody's left out. Do you guys get that? This is the weird thing that can happen with or. Empty set is the weird thing that can happen with and. Or could just include everybody, and could exclude everybody. Right? All right, good. I like it. Perfect segue. How do I write this interval notation?
Parentheses, negative infinity,
Negative infinity up to?
infinity.
Yeah, I don't stop. And real quick, before we do this, number 4, let me go back. How do I write number 1 in interval notation? Yeah, I like it. You should expect the answer to have 2 parts to it because the graph has 2 parts to it. Here, the graph is one big part. The answer should be one big part. Everything. How do I write? What about number 4 now? So you got to be bigger than 3 and less than -3. It's like me saying, yeah, I'll give you the scholarship if you are a human and you are a stingray and you lived on Jupiter when you were young. What the shit? So you don't have any money. Yeah, that's what I'm saying. So what's the answer to this? What numbers are greater than 3 and less than -3? No freaking numbers, right? I mean, there's no point to writing like an empty number line. Empty set covers everything. How you guys feeling so far? Is that all right? So and can have the consequence of leaving everybody out. We can just say and then nobody gets in. Or it could let everybody in. Those are the 2 possible extremes. What's an or normally look like? That. What's an and normally look like? That. And then there's those 2 extremes that could go too far. Yes, here.
I just don't get how you do this.
So tell me.
Because like less than 3 or x greater than 3, but less than -3.
So it's got to be any numbers that are in the answer to this have to do both of these, right? It's an and. So what number is greater than 3 and at the same time less than -3?
Oh, okay.
That's the and. That's what the official meaning of and is. In English, we kind of use it in a lot of different ways. Math says, screw it, let's get one definition for the damn thing. Well, let's do 5 just for a couple reasons. Because there's a fraction there for one thing. Just remember how to do that. Hey, come on now. Do you have more than one side? Yeah, you got 3 freaking sides. So that's when fraction should not be a problem at all. That's the one time you're allowed to. When you have more than one side, you can kill them. first thing I do is multiply every side by 2.
Like it.
And also, now if you weren't here yesterday, I try to make a big deal of this because a lot of people end up doing this. You go, man, that's too many freaking inequality symbols. Let me just subtract 2 and kill this. You can't do that. If I subtract 2, what's still here? 0. I know 0 screws us over sometime, but you can't do the same thing to 0. Too bad. It's a number. It's an actual valid number. What do I focus on? Of course, when I'm solving, I'm trying to get the letter by itself. That's what I'm trying to do. So what do? Add 3, 2, all sides. Less than or equal to 2K? Alright, I got it. And then, about 2 every side. You can't say to yourself, I don't like fractions, let me just not divide everything by 2. No. Why does it really not matter? Because you're not in Math 88. I'm not going to make you do a complete number line like you did in Math 88 to find 13 over 2. I don't give a shit. If you don't know how to do that now, what can I do? Jeez, you got to this point, oh well. There, that's all you got to do, right? Just put those on the correct side of each other. What symbol do I put on 5 halves?
Bracket. Parenthesis.
Must be the other dude there, right? And then you just put the jelly in there. And again, just to remind you, I don't think we had a problem yet that really did this, but if there's a negative, if this was in a negative 2k, if I divide by negative 2, I have to flip all the signs. As always. Okay. So any questions about that? That's section 8.1. By the way, your evil teacher went in and put section 8.1 part 2 into my math homework. Ha! So there's really not just 4 problems. I put some more problems in there. That's my fault. Oh well. Now you get to do it. If that bothers you, that's you there. Oh. I don't know if I've said this yet. Did I freak you guys out earlier this semester with this? Alright, so let me freak you out now. I mean, what is the absolute value of negative 4, for example? 4. Well, what's the absolute value of 3? 3. So does the absolute value always do the same thing? Not really. Did it do something to 3? No. Did it do something to negative 4? Yes. So let me ask you again. Does the absolute value always do the same thing? No. That's why personally, this is a very strange thing to hear a math teacher say. I don't like absolute value. It's evil. It's kind of like not a single thing. And actually, the thing I just took away there, this explains to you there are 2 different things it does. When does it change the number? If the number is negative. And how do I change a number? How do I make a negative become a positive? The easiest way is to multiply it by negative. So look what this says. This says, if the number is negative, I'm going to multiply it by a negative. I'm going to make it positive. People see this and they say, wait a minute, Jeff. That's negative. No, it's not. It's negative times what kind of number? Negative. So in that case, negative x is a positive number. Just like negative 4 is positive 4, right? So this really tells you the absolute value is 2 different things. To me personally, I think it shouldn't get its own symbol. Now, if you go further in math, this starts to mean more, and then it makes more sense. It does mean distance. And when you start doing higher dimensional math, oh shit, talking about distance, and oh yeah, I'm not going to go there. Then it kind of makes more sense. Here, this is kind of evil. But we'll deal with it, because it exists. Now, so these basic questions, dear God, do not have any problem with these, right? Don't. If you do, that's a problem. What is this? 5 halves. All right, that's all I'm going to say. Right. Basic absolute value. Better be able to do that shit. Now, let's do this, yeah. Here, you guys fill in these. Here's the function, right? Fill in these x, y tables. Remember, f of x is just y. You guys can do it. And then try to graph it. See what happens. Some of you guys should already know what letter in the alphabet absolute value looks like. Not sure the little boxes are there. Okay, this should be really quick, right? But all of these become positive with those. Absolute value is 0, that's, 0. And then these stay the same because they're already positive. So negative 4 goes to 4. So you get this, so it's coming in like a normal y equals x line. That's the y equals x line right there. That's y equals x so far, right? But then what's it got to do when it gets right here? It goes, oh shit, it can't be negative, so it makes this hard turn. If this was a plain flight path, everybody's dead after this point. Can't handle infinite gravitational accelerations to it. Thankfully, it's not just ink on a paper. Nobody had died. We're going to do this part in the lab, the graphing calculator part. But what does this look like, sort of? So what else can't be negative that has this turn in it? Well, parabola, x squared. Why is x squared curvy? Because it's not to a first power. Anything to a first power has got to be straight line. So why does this guy have a kink in it? Because it can't go negative. So it's just got to, it goes, bam! Oh shit. Whereas a parabola goes, same idea really, says, I can't be negative, let me just turn around, and now you can survive that turn, right? It's a nice gentle turn. Oh. Absolute value, everybody's dead. Inside of the plane is a mess. It's not good. You didn't have to say that, John. Oh. Now, look at this. Can somebody tell me? So now we're going to start. Now that we know absolute values, and we knew absolute values before today, we learned a few little new things. But now we're going to start putting absolute values in equations. We're going to start putting absolute values in inequalities. And that's when the haunted house and the restraining order is going to come out. But just think about this. Don't think about this algebraically. Just think about this as, what do you take the absolute value of to get 5? 5 and negative 5. What's the absolute value of negative 5? 5. And why does this make sense? If I look back at my graph I just drew, what inputs have an output of 5? Negative 5 and 5. So if you look, what inputs have an output of 3? Negative 3 and 3. Do you guys see that? That's a graphical way of seeing why it makes sense. That's why x squares have 2 answers. What do I square to get 4? I was going to say 5, but that's kind of gross. What do I square to get 4? 2 or negative 2. Why does it have 2 answers? Because it goes like this. What has an output like this? Well, 2 things have an output like that. So this has got that same idea of kind of going back on itself. So that's why there are 2 options, 2 answers possible. Something. What if I said this? Why? Please, you gotta let this be. Easy. I always get people give me answers, but then because we're going to talk about a general process to use to solve these. People use the process and get answers here. Why can't there be answers here? Because the absolute value is going to always be positive. So from the beginning, this equation is bogus. And I know I'm big on showing work, but I'm also big on understanding ideas. The more you understand, the less you should have to do. Right here you go, bogus. empty set or no solution or whatever the sheet wants. Okay. Yes, sir.
If we were actually like, if you put down a test and we actually wrote bogus, would that be clear, right?
I like it. Yes. A little tear going. Just don't get too excited, put bogus in too many places. Alright, so let's try a real equation out. Here, look at number 2. Now here's the idea. What does 2x plus 1 by itself represent? Just 2x plus 1. What does it represent? You can do it. What does x represent? What does x represent? Does it represent a bus? Does it represent an insect? Does it represent a loaf of bread? A number, thank God. So what does 2x plus 1 represent? A number. So really this is asking me, what do I take the absolute value of? What can 2x plus 1 be? What do I put in the absolute value so I get 7 out? Well, 2x plus 1 could either be, the inside could be 7. Oh my God, Jeff, that's right. The inside could be 7 or negative 7. You guys, right? Is that okay? What can I put in here? What can I replace 2x plus 1 with? What could it equal so the absolute value of that thing is 7? Well, either it could already be freaking 7 or negative 7. Okay, I like the way 7. That is a general way to do these things. You say the inside is equal to a number or it's equal to the opposite. Yes? What's that? And then you just solve both. Right? So yeah, minus 1, x equals divide by 2, right? Equals 3, minus 1, divide by 2, yeah, x equals negative 4. And you can check them just like always. Plug them in, see if they work. Yes, sir.
Do you have to do the or symbol between them?
No, you don't really. Yeah. Where am I at? Well, negative 7 minus 1 is negative 8.
X equal negative 4?
Yes. Negative 7 minus 1 is negative 8. Divided by 2 is negative 4. Yeah. I know I didn't show the steps there, but those you should have to be able to do the steps. Alright, so let me let you guys try. Well, let's see. You guys try number 1 there. I'm not really sure what's up with this document has like measles or something. But oh well, just deal with the little boxes. So do number 1 there. No. 2x plus 1 is the number inside the absolute value. So what number could I make 2x plus 1 equal so that after I take an absolute value of it, it becomes 7? So let me say that quicker. What do I take the absolute value of being 7? 7 or negative 7? So the thing inside could equal 7 or the thing inside could be negative 7. That would make the output 7 in both cases. I like it. See? But I'm glad you said it, because that's an easy way to not look at it correctly. Yes, ma'am? You won't always get 2 answers. In fact, I gave you an example a second ago. If I would have made that negative 2, there would have been no answer. You with me? And sometimes you might actually get 1 answer. So watch. So how do I say that? What's one case? What's the first case? Either x minus 5 is 2 or negative 2. And then you solve. Add 5, you get 7. Add 5, you get 3. Now please, dear God, let me 2 things. Absolute value of x minus 5 is not x plus 5, right? I understand that to some degree. At the same time, I don't. Absolute value can't change a part of a number. It's got to change the number. And what's the number? X minus 5. right? What's 8 minus 5? 3. What's 8 plus 5? I made a whole different number if I just changed a piece of it, didn't I? Oh, shit. So you can't ever just change part of the expression. That's not what the absolute value is able to do. You guys with me? I get that all the time. Secondly, I want to look at this problem in a different way, and then I'll let you guys out of here. What's absolute value? I didn't say this earlier, but you guys should know this. And I sort of did say this if you caught on. What's the absolute value represent? Physically. Distance. And that's a really quick way to remember why it's always got to come out positive. Because even if I turn around, you're still 4 feet away from me. If I say you're negative 4 feet away from me, you're inside me. Quick. No? Total recall? No. But watch this. So what this is saying is, the distance between some number and 5 is 2. Well, what's 2 away from 5? Well, if I go up, what's 2 away from 5? 7. If I go down, what's 2 away from 5? 3. And, of course, the answers we got were 7 and 3. That's another reason to see why those answers make sense. Do you have to do it the way I just did it? No. In fact, this problem, the way I just did it, would be much more difficult because there's more shit happening before x. It's not quite as immediately obvious what it looks like. So you don't have to do it the visual way, but that's a nice way to remember why it makes sense. There's 2 answers, because there's 2 ways I can go. Okay. That's enough. Oh, sorry.
I was going to say, so is it always 2 answers or 1 answer?
No, there are situations where you can get 1 answer. Believe it or not. Or other things. We'll get there. We're not quite to that point yet. This